Hey everyone, and welcome to the EZ MIDI 2 video tutorial series. Whether you are a pro pedal builder or DIY enthusiast, EZ MIDI 2 is your toolkit for designing incredible effects with modern features like savable presets, full MIDI control, tap tempo, and a smorgasbord of LFO options. The best part, you can use any of these features you want and ignore the ones you don't need. It's a choose your own adventure for effects design. And to get started, a fully featured free version of EZ MIDI 2 can run on an affordable STM32 Blue Pill development board. To integrate into your effects, you can use an STM32 microcontroller on your own circuit board. In this video series, we're going to take you from a blank Blue Pill board all the way to a fully programmable MIDI controllable filter effect. For the first video in this series, we're going to cover two things: a quick look at why you'd want to use EZ MIDI 2, and then a rundown of everything you'll need to get started. So why EZ MIDI? What does it actually do for you? Imagine you have a great phaser circuit, but you want to add multiple LFOs. With EZ MIDI, you can choose LFO shapes with a knob and customize the LFO selection. Maybe you want an LFO to sync to a click. That's where tap tempo and MIDI comes in. Or maybe you want MIDI to switch between two completely different sounds. You can do that. Perhaps you want a single magic knob that turns off and on multiple tone control schemes. All of these customizations are saved in an EEPROM. Once you've designed your dream effect, you can copy that EEPROM and drop it into another build. It's powerful and flexible enough for professional designs with a low barrier to entry. So, how does this all work? It's simple, really. With EZ MIDI, your knobs and switches don't directly control the effect circuit. They control EZ MIDI, and then EZ MIDI controls the circuit. Think of it like a smart translator in between. This approach makes recalling settings with presets possible, or have effects perfectly synced and controlled via external MIDI. Now let's take a quick look at the Blue Pill board. The STM32 microcontroller is the brain of EZ MIDI. Input pins. The yellow pins connect to momentary switches, one for tap tempo and one for bypass. Green pins are analog inputs. First is an input specifically for the audio signal input, primarily used for envelope followers or envelope-controlled LFOs. Control pot 8 is always for preset selection. The remaining control pot inputs are customizable to control other outputs of EZ MIDI. The outputs. The blue pins are for the bypass outputs. These can be customized for latching relay bypass or analog switch bypass. Simple, clean, and also MIDI controllable. The purple pins are PWM outputs or pulse width modulation. They are your Swiss Army knife for controlling anything in the circuit. For modulation-based effects, you'd use one of these as your LFO output. They can also be used for voltage control or digitally controlled attenuation. You can find a lot more information on how to implement this in the documentation. Orange pins are for serial communication. These pins connect to digital pots, a display, EEPROM memory to store presets, and most importantly, MIDI. So let's talk about what you need to get started. You'll need an STM32 Blue Pill development board. You'll need an ST-Link programmer to upload code to the Blue Pill board and a computer with a MIDI interface. A bill of materials is in the video description with links to less common stuff, like digital potentiometers, the EEPROM chip, and the OLED display, which is fantastic for giving you real-time feedback. To follow this tutorial, we recommend a 3-tier breadboard. This layout gives us space to build the entire EZ MIDI 2 control system. At first glance, this might look complicated, but this setup includes everything, including the EEPROM programming tools and every possible option EZ MIDI 2 offers. You only need to wire up the features you want to use, but with a full setup, you'll be prepared for future designs. You'll also need a separate standard breadboard to build your actual prototype effect. This keeps the brain of the operation separate from the muscle, making debugging and experimenting much easier. It also keeps the different supply voltages separate. So that's the big picture. In the next video, you'll learn how to get EZ MIDI 2 up and running on the Blue Pill board. If you have any questions, drop them in the comments. Don't forget to like and subscribe to keep up with what happens next. Thanks for watching, and we'll see you in the next one.